Why hello friends, Jen Foxbot here for another edition of Math Mondays, yeah! Okay, thanks very much for joining in this third installment of Algebra. Woo! Algebra! Super useful. So in keeping with our spirit of tackling things that are tricky and focusing on big picture concepts, I wanted to talk about exponents and exponential growth in this episode. So let's dive right on in. What is an exponent? Well, whenever we see a number with a superscript or a thing above the number, that is an exponent. And sometimes it's called a power, but you can see them written in many different ways. There are lots of examples, 3 to the third, 10 to the 10, that's a very big number. So all of these numbers, these teeny little numbers up above the number, those are exponents. Cool. So just like when we are learning the rules of manipulating variables and doing basic calculations with different variables, we have to learn the rules of doing various calculations with exponents. But don't worry, it's not that bad. And as you probably know, I push for understanding versus memorization. So we're going to talk about the major rules of exponents, but we're going to talk about them in terms of understanding what's going on. Okay, so first of all, when you have two numbers that are multiplied together and they are the same base number, so in this case we have x and x, those are the same. If we had 2 and 2, that's cool, those are the same. But if we had x and y, this rule will not apply because these are not the same. But the product rule of exponents tells us that we can add these two numbers together. So what does that look like? It's just x2 plus 4 equals x to the 6th. Same thing here, 2 plus 4, so we get 2 to the 6th. But this, we cannot combine because it's different information. And we have to keep that information separate so that we are keeping the right information within the equation. So the only way to simplify this is to just write it like that without the dot and just knowing that these two are multiplied together. Why does this work? Well, if we wanted to take some time and write out all of these numbers, we would get x times x times x times x times x times x. Oh, I'm way too lazy to write that all the time, so that's why we use exponents. But you can see that when you write it all out, you can count them to figure out what exponent you're going to have at the end. So in this case, we have 1, 2, 3, 4, 5, 6. X 6 times. Pretty straightforward, right? Cool. Okay, so to generalize this rule, which is what we like to do, because these numbers can change, but the rule does not change. So a general form of the rule would be to say that for any given exponent, let's say we have a number a times x to the b, then we're going to have xa plus b, x to the a plus b. Cool. So that is rule number 1. Rule number 2 is kind of the, power to the power rule. So if we have x squared raised to a power, then we actually multiply. So in this case, we would get x 2 times 4, which is x to the 8th. And again, this is true, that's funny, true in general. So you have x to the a to the b equals xa times b. All right, what about fractions? What if we divide exponents? Well, let's say we have x to the 4th divided by x to the 2. This actually equals x for minus 2, which is x squared. And so this is kind of interesting. You might be like, wait, there's a negative? What? Yeah. So as a little bit of an aside, another way to write fractions with exponents is actually to use negative numbers. So if I were to write x to the negative 2, that would be the same as writing x over 1 over x to the 2. Same thing if I had x to the negative n, that would be 1 over x to the n. All right. And so again, I'm going to write this as a more general rule where I have x a over x b equals x a minus b. Okay, cool. Let's see, what is next? What if we have two different exponents? Let's say we have x over y squared. Well, in the same case as when we just have two variables multiplied together. Oh no, I got a little blurry, boop. Okay. Then we just apply the exponent to both of the variables, like so. X squared over y squared. Pretty straightforward, right? Not so bad. All right. Okay, what is our next rule? Ooh, okay, so this last one is my favorite, and here is why. So remember in the last video how we talked about a lot of higher level mathematics is dealing with rewriting equations in a way that makes more sense, or in a way that allows us to more easily solve the equation. So there's all sorts of tricks that mathematicians and physicists and other scientists use to rewrite equations. The Higgs mechanism, the particle or the field that gives mass to other particles in the universe, the Higgs field actually came out of a physicist simply rewriting a fundamental law of physics. And when he rewrote it, keeping both sides the same, there was this new field that popped up and did exactly what he wanted it to. And there are a few folks that did this back in the 60s. Recently, they were awarded the Nobel Prize after the Higgs boson was actually detected by the Large Hadron Collider in Geneva, Switzerland. Anyway, that's an aside to say that there is real physical information that we can pull out of equations by rewriting them in different ways. So this trick is super useful. And one of the most common things is to use the properties of the number 1, because there's a lot of really cool things about number 1. For example, when we divide the same number by itself, or when we divide a number by itself, we get 1. So for example, 2 divided by 2 is 1, 10 to the 1,000 divided by 10 to the 1,000 is 1, x divided by x is 1. Boom, pretty straightforward, right? So we can do the same thing that we did here, but with exponents. So check this out. So if I have x to the a divided by x to the a, that equals 1, because they're the same number. But this means that I have x a minus a, and a number minus itself is 0. So all of a sudden, I just showed that x to the 0 is 1. What? And remember, x can be any number, any real number. And so if I have 10 to the 0, that's 1. If I have 100,006 to the 0, that is 1. So any number raised to the power of 0 equals 1. So these are our 4 major rules of exponents. The trick to learning these is practice. So find yourself some practice problems. I highly recommend finding problems that have answers so that you can check your work and make sure that your understanding is correct. Cool. Okay, so if that is all that your brain can process at this point in time, that's fine. So if you want to take a break at this point and go off and do something fun and then come back, we are going to now dive into exponential growth. Yeah. Okay, so this is part 1, and part 2 we'll talk about exponential growth. Cool. All right.